We've just finished going over how to multiply monomials, and we're going to follow that same train of thought, and we're going to get started on polynomials and those types of operations. So let us get going with our polynomials unit. And I think a lot of students say they like this type of stuff, and this unit, one of my favorites, just because I like polynomials too, and I think it'd be something that you all enjoy as well. So since we're working with polynomials, our essential question is going to be centered around that. Okay, our essential question is going to be, how can I add and subtract polynomials using algebra tiles and algebraically? So how can I add and subtract polynomials using algebra tiles? Ooh, I can't type today. And algebraically. All right. And if you're not quite sure what algebra tiles are, we're going to be doing those like literally next. That's what this next thing is going to be. So our next thing is going to be defining what an algebra tile is. So just scroll down a little bit and then boom, here. Let's do purple for today. Actually, I want to do green. All right, algebra tiles are made up of small squares, large squares, and rectangles. Okay. Small squares, large squares, and rectangles, and they each represent something. So where this says term, that's going to be what they each represent respectively. Um, this is in blue. I think I'm going to use some different colors. For my x, this big square here, that's our x squared. The rectangle that we have is just x. And then I'll use black for this. This singular yellow square here, this is just 1, okay? Or our constant term. All right. And that'll be useful moving forward. Oh, these are supposed to all be in different colors. Hold on. So our x squared is in purple. That's one term. Our just plain old x is another term. And then we have our constant term, which is in yellow. All right. That'll be 1. And I'm going to write these in black. I don't have colors that correlate to these that you'd be able to see. They're really, really bright colors, are hard to see when I'm doing this video. So I'm going to use purple for my x squared, pink for my x, and then black for my constant term for that one singular rectangle. All right. And so once again, here we go. We're going to just define them all again. The number 1 is represented by the yellow square. The variable x is represented, x, that should be a different color. That x is represented by the rectangle, and the large square represents the x squared. Okay. And this, I really wish I had the same colors to use, because that would make this a little bit easier, but unfortunately I don't. When we do this, another thing to keep in mind is that we have these things called zero pairs. All right, zero pairs. Zero pairs, those are the things that add together to get 0. Those are called additive inverses. Okay, there's a little math term for you. The additive inverse is when you add them together, you come away with 0, or they cancel each other out. So they cancel each other out, or they equal 0. So when we look at these, if we take, remember this yellow square here, and I do have a yellow, slightly different. Oh, well. When we take this yellow square here, this color square, and one red square, represents a 0 pair. Okay. So this color square here, this 1 here, this is positive 1. And then this red square is a -1. So if you add those two together, you end up with 0, right? That makes sense, right? And the same thing with these two. My rectangles are my x's. So I have an x plus a negative x. Once again, we get 0. And so now what we're going to do is look at an expression that is represented by algebra tiles, and then we are going to simplify them, all right? So we've got these blue here. These are our x squared tiles. X squared, x squared, x squared. Remember, our rectangles are just x's. And these red tiles, we think of these as a -1, all right? We can think of these as a -1. Whereas these yellow tiles, these can be just the regular 1, 1, 1, 1. And I can't write -1 in red there. I don't think you guys will be able to see it. Yeah, you can't see that. I can't see that. So look, we've got how many total x squareds? 1, 2, 3, 4, 5 x squareds on this side plus the 1, 2, 3 x squares on that side. So that's 5 plus 3. That's going to give me 8 total x squareds. And then how many x's do we have? We've got 1x here, 1x here, but then we have a negative x. Ooh, that's really hard to see. All right, that's a negative x, that's a negative x, and that's a negative x. So we've got 2 positive x's, but 3 additive inverses, or negative x's, we could just call them those. So that's going to be a negative x in total. So 2 plus -3 gives us a -1. And then we have how many of our constant terms? We've got 1, 2, 3 negative ones, or 5, 1, 2, 3, 4, 5, 6, 7 negative ones over here, and then 3 positive ones. All right. And so I'm kind of doing this a little bit out of order, but once we count all of them up, we've got these 3 positive ones plus a -7. All right. All right. 3 plus a -7, or -7 plus 3 gives us a -4. Okay. And so that's how, ooh, 1 second, y'all. Here's a really good thing. Glad I missed it going forward, but here's something that's super duper easy to miss your some values. Okay. I completely forgot to write my x here. If you forget to write your x and you end up writing your constant terms, you'll see that one constant term plus or minus another constant term gives you a constant term, and you'll end up getting these things wrong. So you want to make sure you're paying close attention and checking these before you move on, like I just did, and catching any mistakes you may make. All right, so once we add these all up together, this is what we end up getting. And if we wanted to write these out algebraically, it would look something like this. We got 1, 2, 3x squared, 3x squared, and then we've got plus 2x, because 1, 2 there. And then we have these -7, -1s, -7. So that's going to be this one here. Actually, let me box that. That's this one. And then we have this one over here where we have 1, 2, 3, 4, 5 x squareds, and then 3 negative x's, -3x, and then 3 positive ones. All right, positive constant terms, +1. All right. So take some time. If you need to go back and rewatch this part again, take some time, rewind it, watch it again, and then try this next one. Okay. I've just done one. Let me draw a little squiggly line. Ooh, squiggly line, so you all can practice the next one. I want you all to practice this one and do this one on your own. All right. If you get stuck or you need help, come back to the Zoom. Ask for help. I'll be more than happy to help you out. All right. But as we move forward, it's important to recall that you can only combine like terms. Okay. You can only combine like terms. You can't combine things that are not the same. For instance, constants. Constants are like terms. So those are just numbers with no variables next to them. I can spell Constants. They have the same variable. So constants are like terms. Also, we have like terms that are the same variable with the same power or exponent. With the same power or exponent. I'll type in exponent. So when we're looking at like terms, they are terms that have the same powers that are constants, or they have the same powers. They're variables with the same powers. So let's look at a couple other examples, and we'll treat these as algebra tiles as well. So example says, translate each of the expressions into algebra tiles before simplifying. I'm going to do one of these, and then I'm going to save the other one for you. And here's where our shapes come in really handy. I'll stick with the color. So we've got 2x squared, so that's 2 squares here, 2x squared, and then we have a minus 7x, so that's 7 rectangles. 1, 2, 3, 4, 5, 6, 7. And these are red because they are the additive inverse portions. And then we finally have 6 squares. All right, and my squares are due in black. 1, 2, 3, 4, 5, 6. So my big squares and my little squares look kind of close, but you guys kind of get the point. So this is my algebra tile setup for my first polynomial here. And now I'm going to do my algebra tile setup for my next polynomial. We have a negative 3x squared. So this negative 3x squared, we're going to have 3 big squares that are red because these are negative numbers. So they're the additive inverses. So we have 3 of these. And then we have just a 7x. And this is a positive 7x. So we're going to have some red triangles. Oh, no, these aren't red. These will be the pink triangles because they are positive. And we'll have 7 of them. 1, 2, 3, 4, 5, 6, and 7. All right. So we've got all of those written out. And now finally, we can actually go through and do the math for these. We have 1, 2 positive x squareds, but then we've got, that's the wrong color, x squared, but then we've got some negative x squareds over here. Negative x squared, negative x squared, negative x squared. So we've got x squared plus a negative 3x squared. That leaves me with, excuse me, that leaves me with a negative x squared as my first portion. Then I've got 7 negative x's, so negative 7x plus a 7x. And that just leaves me with nothing. All right. And so what we end up with is just this negative x squared. And then we've got these 6 just regular squares over here, negative x squared plus 6. All right. And there we go. Now I want you all to try that second example on your own. And now when we look at this next portion of notes, when we deal with subtraction, it's important to remember that when we are subtracting, we must distribute the negative before we combine like terms. All right, distribute the negative before we combine like terms. So this example says, translate this polynomial here into algebra tiles and then simplify. So my first step, I'm going to let you all translate these into algebra tiles, but I will show you what the first step is because a lot of students seem to struggle on this. So we still have this negative 3, I'll write this in the colors to try and make it a little bit easy for you all. Negative 3x squared plus, and I'll underline that in red because those are negatives, negative 3x squared plus 6x, and then we've got a minus 4. And then we have this minus, so this minus needs to get distributed to that term, that x squared, into that negative 2. When we distribute a negative to a positive, that becomes negative. So we've got in parentheses now. Once we distribute it, it also becomes a plus. So this becomes a plus. This x squared becomes a negative x squared, a negative x squared. And then this minus 2 has now become a plus 2. Okay, so you all go ahead, translate that into algebra tiles, and then do the following example on your own as well. And once again, if you get stuck at some point in any of this, come back to the Zoom chat and let us know. And then we'll also do that final example. And these are all just practice problems. So if you get stuck or you need to rewind it to rewatch something because it's not making sense, come back to the Zoom chat. And like I said, go ahead and let us know. With the second example though, with this one here, you don't have to translate that one into algebra tiles. You can do that just using the numbers. Now, finally, let's look at a real world example. This says to find the expression for the perimeter of this triangle. So anytime we want to find the perimeter, that's just going to be, we're going to add up all the outside edges. So perimeter for a triangle is going to be base plus base plus base. And what that's going to look like is this 2x plus 2y plus 3x plus 4y plus 5x minus y. All right. And this looks pretty similar to one of the types of problems we've covered in the past. Actually, like that problem we had on the test. I'm going to go through quickly and just underline my like terms. Remember, we can only combine our like terms. And when we combine these, we have a 2x plus a 3x, which is 5x. And then that 5x plus this 5x. 2 plus 3 is 5 plus 5 is 10. So we have a 10x. Let me bring it up a little bit. A 10x. And then we have to do our next set of like terms, these y's. 2y plus 4y is 6y. Then we have this minus y. So that's 6y minus y, which gives us a 5y. So plus 5y. All right. That's how we do those types of things. I've done that one as an example. And so I want you all to do this final one. Find the perimeter of the garden. And this garden, now careful when you're doing this, this garden has 4 sides, but they only give you 2 different expressions, 2 different polynomials to work with. So you'll have to do a little bit of cognating, a little bit of thinking about how to do this problem. Once you finish this problem, go ahead, scroll down, go ahead and do your summary. We'll do this as the muddiest point like we've done in the past. You'll type out what part you got confused on, how you get unconfused, whether you had to go think about it, rewatch it, or rewind something, or come and get help from one of us. Once you are done with this, we do have a classwork piece for you to get going on. If you get stuck with this, then by all means, go ahead, come back to the Zoom chat, ask one of us, or rewind it. All right. So yeah, once you get done with this, go ahead, start working on that classwork, and we will get you going after that. All right.